Hello, and welcome to the Center of Math series on stats in the NFL. This is part 4. We'll be talking about a Pythagorean expected wins today. So in the NFL, what tends to happen is that at least one team that came last in the division the year before tends to come in first in the division the next year. And a lot of this is because while wins and losses are binary, you can either get a win or a loss. A win by 1 point is the same as a win by 20 points. So the closer wins tend to be luckier than the dominant wins. So Pythagorean expected wins is a stat that tends to take luck out of the equation and sort of wonder how teams would do or how they would be expected to do based on the points they allowed and the points they scored. So the formula is as follows. So the formula here is, so the Pythagorean expected wins is equal to the number of games played times the points scored to the 2.37 divided by the sum of points for to the 2.37 plus points against to the 2.37. So as you can see, this formula rewards teams that score a lot more points than opponents rather than teams that merely come close in games and barely win. So if a score of a game was, say, 49-48, both teams would have an expected win probability of about 0.5. The winning team would have a slightly higher probability, but the winning team would also just get a little luckier as well with the win, versus a team that shuts out the other team in victory have an expected win probability of 1 win for that game. To sort of demonstrate this in action, we have 4 hypothetical teams, and they've all played 8 games. So you can see the win-loss records of all the teams. The best team goes 7-1, the second best team goes 5-3, and 2 teams go 2-6. You can take a look at the points for and points against. So the best team, 195 for, 116 against. Second team, 174 for, 173 against. The team in third, 122 for, 146 against. And the team in last, 118 and 174. So what we're going to do now is calculate their expected wins to see which teams overperformed and which teams underperformed. So you can see Team A, they still did better than average. They averaged 6.19 wins, or that the expected wins is 6.19 wins, which is still a good record, but less than we would have expected. So as you can see from the point difference, over 8 games, they only outscored their opponents by a net total of 1. And this is reflected in the expected wins, where despite winning 5 games in these 8, they were expected to only win half of them, which reflects the fact that more or less, on average, they score about the same as their opponent every game. And then even though Team C was still outscored in all of its games, we find that it was a little unlucky when it won only 2 games, as the expected wins are a hair over 3. And now for the final team. So you can see Team D had the worst point differential of minus 56. And it's reflected in its expected wins being the lowest of the 4 teams. You can still see they got a little unlucky, only winning 2 games. And so that explains how point differential can show you which teams got unlucky and which teams did get lucky. Thank you so much for watching this video. Be sure to subscribe to the YouTube channel, check out our website, thecenterofmath.org, and follow us on Facebook and Twitter. Thank you.